Hello students, my name is Venugopal and today I am going to give you an introduction of finite element methods tuition, just an overview. So in this tuition what we are going to cover is that in this short video I am going to show you. So basically finite element methods tuition is designed as per the JNTUH syllabus and it will be customized as per the student requirement. So basically what is the finite element methods? Finite element methods is a numerical method to solve the engineering problems, and so the problems could be of any type, like structural problems, mostly structural problems, or heat transfer problems, or thermal problems, or sometimes vibration problems, which is not really important in this B.Tech level. However, let's come back to the FEA. FEA is again, it's a numerical methods technology. We apply numerical methods to solve the engineering problems. So how does it happen is very interesting. So what we do is, as the name says, we break down the large problem. We take the large problem. Let's take a car crash, for example. So when a car is crashed, it's a large problem. So what are all the different stresses happening in that collision, or what is the structural deformations happening, how much is the deflection, all these things we have to understand, so while designing the car itself. So in order to understand that, we take the bigger problem, which is a car crash, for example, and we break down the large problem into small elements, small problem, like small elements. So we take a complex object and we break down into small objects. That's nothing but finite elements. So we study each element individually, and then we combine those small elements results into a larger element back, and then we understand how the effect of those stresses or heat effects on the whole system. So in this particular tuition, I am going to cover mostly these are the topics, that is one-dimensional problems. Like I said, when we break down the large complex problem into small elements, so these elements could be of one-dimensional or two-dimensional, or it could be any tetrahedral, so like that. But in our syllabus, we are going to deal with one dimensional problems initially. Those are nothing but, like, one dimension means one, only we have one x-axis or y-axis, this type of thing. And in the second unit, we analyze the stresses and beams. What is a stress means? Basically, if you see the bridge, you would have seen the like foot over bridge. So there we have a lot of angular objects combined together to make a foot over bridge. So those are nothing but those small elements are called trusses. So we can analyze those trusses and understand the what are the deflections and what are the other forces, all these things. So that is about second unit. Third unit, again, it is a two-dimensional stress analysis and axis symmetric analysis. So two-dimensional, nothing but like a bar element, or anything which has two-dimensional and axis symmetric objects. Fourth unit covers about the steady state heat transfer analysis. So as I said, the finite element methods can be applied to structural as well as heat transfer problems. So heat transfer problems, again, we can do the conduction, convection type of problems we can solve by using FEM methodology, by applying the numerical methods. And finally, we do the dynamic analysis. We can study about dynamic analysis using the FEM. So these are all the topics which we will be covering in the finite element methods tuition. So I will be discussing very detailed, and we apply these numerical methods to solve the problems with respect as per our examination question is, and we can solve the problems, and as well as we can attempt to the theoretical questions also. And that's how this tuition is going to be structured. And so that is about this particular tuition. I hope